Okay, let's look at the homework 4.2, 4.3, problem number 11. Right, so we have this function c of x is equal to x to the 1/3 power times quantity x plus 4. Right, so we want to find the interval of increase and the interval of decrease. Right, so let's do that first. Alright, so in order to do that, we need to find the derivative. So let's take the derivative. So c prime of x is equal to, right? So you have two things multiplied together. So this is our first guy, and this is our second guy, right? Then we have to use the product rule. Right, derivative of the first guy would be 1/3. Right, x, raise it to the subtract 1 from the power, so negative 2/3. Right, times second guy, so quantity x plus 4. Right, and plus first guy is x to the 1/3 power. Right, then your derivative of the second guy would be just 1. Right, then let's rewrite it a little bit so that we can set it equal to 0. Right, so here since you have a negative power, we should really put x on the bottom. So on top you have x to the 4th, right, sorry, x plus 4 I meant, over, right, 3 is on the bottom. Right, then we put this guy on the bottom at x to the 2/3 power. Right, then here you have actually maybe we should extend it this way. Right, then if you take the common denominator, so this is 3x to the 2/3 power. So x to the 1/3 power would be, so you have to multiply this guy by 3x to the 2/3 power. So it's going to be actually just a plus 3 x, right? Because x to the 1/3 times x to the 2/3 is going to be just x. Right, so this is going to be, so this is 4x plus 4. So I'll just pull out 4 as well. So you have 4. And 4x gives you x, and 4, so plus 1. Right, all over 3 to the 3 times x to the 2/3 power. All right, so we can set this guy equal to 0, and we'll see that we want x plus 1 to be 0, so x equals negative 1. Right, setting the numerator equal to 0, we get that. And also we have c prime of, right, looks like if you have 0, then the denominator becomes 0. So this guy is undefined. Right, so which gives you two critical numbers. So critical numbers are, right, x equals negative 1 by setting that equal to 0, and when x equals 0, c prime is undefined, so 0 is also a critical number. Alright, then we're gonna do a number line. So let's just draw a number line here. So you do a number line there. Alright, then we're gonna put tick marks where the critical numbers are. So let's see, negative 1, we have 1, so here's going to be 0 there. Alright, so let's look at the sign of the c prime, first derivative. Alright, so we can try any number less than negative 1. So we try c prime of, say, negative 2. Alright, then we just need to figure out the sign. So here's the derivative. Right, the denominator is always positive because there's a square involved. So the denominator is always positive. All right, then let's look at this guy. All right, so you have, if it's a -2, so -2 plus 1 is negative, so it's negative on top. All right, so negative over positive would be negative. All right, so make sure that I'll say this is negative. And let's say between -1 and 0, so we can try c prime of -1/2 or something like that. All right, if you plug in -1/2, so that will be positive. So then the whole thing is going to be positive. All right, so we have that. All right, something bigger than 0, so you have c prime of, say, 1. All right, then you see that's going to be positive here. And the bottom is always positive, so it's going to be positive here. All right, so it's we have that. All right, so let's see. So find interval increase. So you can see that it's going to be from -0 to all the way to positive infinity. All right, so let's type it in. All right, so it's going to be interval increase would be -1 to positive infinity. All right, oops. And the decrease would be -infinity to -1. All right, so let's check the answer first. All right, it came back and looks like we got these ones correctly. All right, so let's do the next problem, part B. All right, so find the local minimum value and the local maximum value. All right, so let's do that. All right, so you can see that here there's a critical number here, -1. So it's a negative, which means that the decreasing and turns into increasing. So by first derivative test, we know that we're going to have a local minimum here. All right, here sign does not change, so it's going to be neither. Right, so we only have local minimum at x equals -1, so we have to find a value there. So part B, and we would have a local minimum, all right, which would be, so c of -1. All right, so if you plug in -1 here, so you have a -1 to the 1/3 power, which is going to be -1 times -1 plus 4. Right, so that will be 3, and with the negative sign, so it's going to be -3. All right, so let's type it in. All right, so local minimum, we found that to be -3. Oh, right here, -3. All right, then local maximum does not exist, so DNE. All right, so let's check the answer. All right, so it came back. Looks like we got part C correctly. All right, so let's move on to part C. All right, so we want to find the inflection points. All right, so let's do that. All right, so I'm gonna make a little bit of room. All right, so in order to find the inflection point, we need a second derivative. So we take another derivative. So C double prime of x. All right, so let's see which is the easiest way. How about this one? I'm gonna try to take the derivative of this. Actually, I'm gonna try to take the derivative of this guy. All right, so quotient rule. All right, and square the bottom. Actually, 4/3 is just a constant multiple, so I'm gonna just put 4/3. just in front, right? Then square the bottom, so that's going to be x to the 4/3 power, right? And derivative of the top is 1 times that derivative times the bottom, so x to the 2/3 power, right? Minus top is quantity x plus 1 times the derivative of the bottom would be x to the let's see, put 2/3 in front, right? X to the, subtract 1 from the power, so it's going to be negative 1/3. Right, so we have that. All right, then since let's see, we don't want to have a negative negative power here, I'm gonna multiply top and bottom by, so I'm gonna multiply top and bottom by x to the 1/3 power, right? X to the 1/3 power. And also, let's see, we do not want to have a fraction here, so 3. I'm going to multiply actually by 3 as well. So I'm going to put 3 there, right? And see what we get, right? So this is going to be equal to, all right, so you have 4/3 is already there, so I'll just put that in there, right? Then a denominator is going to be 3 times x to the 1/3 and 4/3, so it's a 5/3. All right. Then you have a 3x to the 1/3 times x to the 2/3, so that's going to give you 3x. All right. Then 3 and 3 cancel out, so and the x to the 1/3 and x to the negative 1/3 cancel out. So you would have a negative minus, right? You have 2 here, so 2x, right? Minus 2. All right. Then we'll clean up a little bit. So this is going to be equal to, all right? So here 4, right? 3 times 3, 9. Right, so you have x to the 5/3 power here, right? Then this is going to be simply x minus 2. Right, and we set this guy equal to 0. All right, then see what happens. So it's going to give you x equals 2. Right, because we have to make the numerator equal to 0. So that's a possible location. All right, then we'll see. So then you have x equals 0 is as well, because c double prime is not defined there. So let's look at the number line again. And this time this is for the second derivative. All right, so here. All right, so here's x. Right, so I'm going to put a tick marks for 0 and a positive 2 as well. Right, then we look at the second derivative, c double prime. Right, so let's look at the sign of c double prime when you plug in -1. Right, so that's going to be negative on the bottom, so this is 5th power negative. Right, so you have a negative 1 minus 2, so that's negative, right? Negative over negative is positive here, right? So this turned out to be positive, right? Let's see, between 0 and 2, so we can try c double prime of 1, right? So 1 is positive on the bottom. 1 minus 2 is negative, so this is going to be negative, right? Right, and how about c double prime bigger than 2, so 3, and that's going to be on top, it's positive, on the bottom it's positive, so this is going to be positive. right? So it's going to be greater than 0, right? So you can see that concavity changes from concave up to concave down. So you're going to have inflection point at x equals 0. So here, inflection point, right? And here it changes from concave down to concave up. So there's an inflection point there, right? So inflection point is going to be at 0 and 2. So we have to find the value of, let's say, C of 0 first. This one's easy. If you plug in 0, it's 0, right? And so C of 2 would be, right, so 2 times 1/3 power, so it's cube root of 2, and times 2 plus 4, right? So that's 6 times cube root of 2, right? So inflection points are, right, so x is 0, of course y is 0, and when x is 2, y is 6 cube root of 2, right? So let's type it in. All right, so first one was 0, comma 0, and the second was 2, comma 6 times cube root. Let's see, is there a cube root there? Not sure, so we can just do 2 to the 1/3 power. How about that? All right, so let's check the answer. All right, it came back and looks like we got the part C, actually these inflection points correctly. And then we have to do find the interval where graph is concave upward and a concave downward. This one we've done the work already, so we should be able to find it pretty quickly. All right, so looks like here it's going to be concave upward here, and since the second derivative is negative, concave downward here, and a concave upward here, right? So between negative infinity to 0 and a 2 to positive infinity, we have a concave up shape. Between 0 and 2, it's a concave down shape, right? So let's type it in. All right, so concave upward on interval negative infinity to 0. And then you have union, so maybe I should do a union, and from 2 to positive infinity, right? And concave downward between 0 and 2, right? Let's check the answer. All right, it came back and looks like we got these intervals correctly as well. All right. That's it. I hope that this was clear.